Let's see. We had implemented several models inside of the models directory, right? So that we can break up all the different artifacts of our implementation, right? All the models are going to go into the models directory. And we implemented a couple models. We implemented a module and course. We also implemented a widget. We said that a course had a many-to-one relationship with modules. So a course has many modules. And this is how we mapped it. We said that we annotated it as a one-to-many. And then the modules had a reference back to the course that it belonged to, right? Using the other side, that add many-to-one, right? So it references parent course. The module itself had a many-to-one with widgets. So one module contained many widgets. And we modeled that again with a list of widgets with a one-to-many relationship to the widgets. And the widgets itself then reference back to the module that it belonged to with a many-to-one, right? So we have a faculty that has many courses, right? One course that has many modules, and one module that has many widgets. So we have all these one-to-manys. And the way we implemented that was that the course has a list of modules, and the module all these modules are pointing to many modules, and the module had a reference to the course pointing back to the parent. Same thing for the modules to widgets, right? This has a list of widgets, right, that point to many widgets, instances of those widgets, and each widget then points back to the parent as a module pointing back to the module, right? So that's how we implement the one-to-many, right, between these. And that's how you annotate it. We looked at the widget as a base class that was inherited by several other widgets. We saw that the widget was the base class that then HTML widget and YouTube widget inherited from. Right, so notice that here we have the YouTube widget inheriting from widget, and we also have the HTML widget also inheriting from widget. Okay. Notice that these widgets, even though they're entities, we're not declaring the primary key ID. Instead, they're inheriting that primary key from the widget that is the turn this off. Okay. The parent widget declared the primary key, and as the base class, you could establish what strategy you wanted to implement the inheritance. Here we are using the joined inheritance strategy, but there's several other strategies, right? There is the single table, which is the default. There's the joined class strategy, which is the more expensive strategy, right, that breaks it up into multiple tables, but then it has to join all those tables to recreate the original instance. And there's the table per class, which is kind of like between the two. It uses multiple tables, but it doesn't use the join, right? Instead, it uses the single tables at the bottom of the leaf of the hierarchy of the inheritance to store the entire data, right? So anyway, so the fastest implementation is the single table, which is the default. Yeah, so we played around with that as well. We then expose our data model through the use of a controller, right? I'm sorry, we implemented several repositories. The repositories provided us with a default implementation for interacting with the database, right? So that it provided some generic functions such as find all, find by ID, delete by ID, save, right? All those are implemented by a crowd repository that we are inheriting from to implement our own repository. We implemented for course repository, we implemented for modules, and for widgets. So we have 3 repositories, and then we played around with these repositories from a controller. The controller, we use the controller to expose this data model through several web endpoints, right? URLs that we can hit those URLs and then execute certain behaviors. So for instance, for creating modules, we created a module, initialized it, and then save, right? And so this is how we inserted a new instance of a module into the database. We also showed you how to remove a module, right, using the out of the box delete by ID. All these functions .save, .delete by ID, all those are implemented by the boilerplate implementation of the CRUD repository. We don't have to do anything to use that. Yes.
I have seen that there are some examples where JPA repository is also used. So, what is the difference between CRUD and JPA repository?
It actually implements, there are several implementations of the repository. There's also JSON repositories, there's file repositories, there's if you want to leave it up to JPA, it will choose what repository it is based on your vendor. It will figure out which one to use. But you can implement your own repositories, right? So if you want to write to your own file system to do some encryption or some, but there are some out-of-the-box implementations to interact with JSON files or XML or any other types of sources, or even network, connecting to a network. So yeah, so there's a whole bunch of libraries that are already implemented that do that. The most common one, the easiest one is to use is the CRUD repository. Yep. So for update, we saw that to use update, we notice that the update implementation uses save here. See that? Just like the save that we use for creating new instances. The difference between using the .save here and the .save here is that in this case, for the creation, we created the module from scratch, right? We own the instance. We created this instance, and then we saved it, and the .save behaves as an insert, right? When it's a brand new instance. If instead it's a instance that we don't own, actually it's already in the database. We just know the ID that it belongs to, right? We can retrieve that object, manipulate it, right, and then save it back in the database, right? So this is interpreted by JPA as an update as opposed to an insert, right? You are manipulating a record that lives already in the database, so it's an update. We also looked at find all modules. Notice that we first implemented it using the boilerplate implementation, .find all, the generic implementation. We improved on that a little bit by implementing our own find all modules, right? That did not exist in there. It still lives in the repository because we wrote it, right? We went in there, right? If we go in there, notice that we wrote ourselves the find all modules implementation, right? We first wrote it in terms of a native query, where we did a select star from modules, right? We're saying, hey, JPA, use this little string, right, to query the database and retrieve for me all the records that match. The JPA part will parse the records that come back, instantiate modules for each one of those records, and return to you in a nice package as a list of modules. We also implemented a non-native query, which is the default syntax, right? The default syntax is not to use the actual names of the tables, the actual names of the fields in the SQL, in the relational database. Instead, is to use this higher level object-oriented way of referencing the tables. So this module class, as opposed to module table, we're saying, give me all the instances of modules that are of type module, right? And notice there's no where clause, meaning we want all the records. Now, which table does this map to? Well, if you go to the modules, notice that we did map it to a table, right? So we know that is the table that we're talking about, right? So we're telling JPA which table to use. We also implemented the find module by ID, again, to override the out-of-the-box find by ID generic implementation. Instead, we wrote it so that we could use the class module as opposed to table modules, right? And then we use the field ID inside of the module instance, class instance, okay? And here we use param to map the placeholder, okay? All right. There's a couple more that in the controller we implemented. We also took a look at how to create relationships between parent and children, right? We have a course, presumably that is a course has many modules, right? So how do we create that relationship, right? Usually if you're going to add a module to a course, typically the course already exists, right? So you would retrieve first the course that already exists in the database. You would retrieve it into memory, which is, I believe that is what we did here. We retrieved that particular course, microgreens course, and here we instantiated a new module, which we're going to add to the course. So we instantiated. We set the we set some a couple modules, seeding module and germination modules, and then we added them all to the course, right? Course.add module. The add module, I believe, was just use the local modules array, right, or list, right, and added it. It also set the inverse relationship as well. It said that not only am I your parent, but now, not only am I adding you as one of my children, but now you know that I am your parent, right? So module.setCourse sets the bidirectional relationship here. Okay. Usually, if this were a Java-only implementation, you would only do this, right? You would add it to your children. Usually, you would not have in Java a doubly linked reference, right, where children know its parent. Where parents know their children, but the children also know their parent. Usually, it's just a one-directional. But because it is being mapped to a relational database, in a relational database, the relationships typically are bidirectional. Right? You just have to say that this primary key is equal to that foreign key. It allows you to navigate both, between the two tables and access references the fields in both tables, right? In the select statement, right? In the where clause, you can refer to all the fields in any of those tables, right? Whereas in Java, usually you would not be able to do that. But because we know we're being mapped to a relational table, we are forcing this bidirectionality. Okay. So we have to support that bidirectionality. And we then save both of these modules into the repository. There's two inserts that are made up into both modules for that repository, making the foreign key back to the course repository. What else? Find module by ID, create widgets. Here we're playing around with creating widgets from a parent widget that then HTML widget and YouTube widget inherited from, right? So we saw that because we were using, which strategy were we using? I think we were using the other one, the joined. Yeah, we were using the joined strategy. We saw that by using the joined strategy, half of the fields in the derived classes were being stored in the HTML table, whereas the other half was being stored in the parent widget class, right? Such as the ID, the name. So the name, right, is a common field that all widgets have, right? So it's stored in the widget table, whereas the HTML and the class name, that's specific to the HTML, so it was stored in the HTML table. Right? So if you retrieve an HTML widget, you would have to join both tables. That's why this is so expensive, implementing it using it as a joined, the joined strategy. And usually we avoid the joined strategy because, not that it's anything wrong, it's just that it's the slowest implementation. If it's a shallow inheritance tree, maybe it's okay, where you only have to join two tables maybe. But if it's a very deep inheritance tree, usually it's better to go with a single table implementation. Okay. All right, I think we're all caught up.